When I started, I said there is a connection between an integral and a series. Suppose I have the function x. Keep things simple. Now I want to go from 0 all the way up to 2. Integrate it. I hope you know what the answer is. Yes, what is the answer? Well, what is the integral of x?
X squared over 2.
X y over 2. Lower limit, upper limit, 2 squared over 2, 4 over 2, you get 2. Good. If I graph this, what would that look like? Huh? It would be a line, that is correct.
Be a triangle. Maybe a triangle.
Oh, okay, I agree with that too. So this is what Caleb and Bryce mean. Goes all the way up to sort of looks, well, not sort of, looks like a diamond. 0 to 2, and I have 2. Good. The function itself is f of x equals x. What I'm going to do is I'm going to pick points from this function. Give me a number between 5 and 15.
49.
49.
Say 14.
Oh, 14, okay. So 14. So I'm going to divide this entire interval into 14 points, 14 individual points. So what is the length of each point?
114.
From 0 to 2, right? So 2 times 1 over 14 is 1 7, right? 1 over 7. But as I move, it can't just be 1 over 7, it's got to vary with respect to the value of x, correct? So I want to generate a sequence. I'll call it the letter n. I want to know the general term for my sequence. What would it look like? When n is equal to 1, I should start at 0, right? Or I could start at 1 over 7. N equals 1, I must get 1 over 7. N equals 2, 2 over 7. N equals 3, 3 over 7. Increasing by 1 over 7 step. I want to find a sequence for this curve. What should it look like? That's my question.
10 over 7. N over 7.
N over 7. If x is 1 over 7, y is 1 over 7, x is 2 over 7, y is 2 over 7. Here, I can go all the way 1, 2, dot, 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 up to 14. Agreed. Going all the way up to 14. If I want to start at 0, this would simply become n minus 1 divided by 7. Do you agree? Okay, we'll save that for later. Some would want to put I there, that's fine. I'm sticking with the n notation because that's how we define our sequence. I'm going to sum these values. Start at 1, go all the way up to 14. With me? So following so far? N over 7. Good, I just replaced it by the general term. Well, when you have a series, just like an interval, if you have a constant here, what would you do? You would just pull it out. Same thing. You would pull that 1 over 7 out. Good. And we want to know what that sum will be. So n is 1, you get 1, and n is 2, you get 2, you're just adding those values to get a 14 partial sum. This is something that you cannot forget. I equals 1 to n I. That is the sum of n natural numbers let's say if I want to add starting at 1 all the way up to 500, adding every single number. I want to know what the answer is. Can you tell me what the answer is? Take a guess. I want to sum from 1 all the way up to 500. What do you think the answer is? It's definitely over 125,000. But if you know this formula, life is easy. It's simply n times n plus 1 divided by 2. So 125 is 1,000 or 100?
1,000.
1,000?
125.
250 times, yes, 125,000. 100 by 250. 125,250. That is the answer. How did we get that? We simply plug in n, the value that you reached. I used 500. 500 times 500 plus 1 divided by 2. You cannot forget this. So, important identity. If I use that formula here, I'm going to have 1 over 7 times n times n plus 1, and here is 14. So 14 times 14 plus 1 divided by 2. Correct. So 7 and 14 get cancelled. Those 2's will get cancelled. I'll get 15 as my answer. But that is not equal to an integral. Do we agree?
I know, like, we just chose the number 14, but what is it representing of that?
This one?
Mhm.
14 points that I'm summing.
Okay.
So if you pick 20, you would be something at 20 points, right? So that number
And
is
then you-
not equal to the integral. Why not? Did we find the integral? Integral is the area under the curve. So if you go back and look at our typical derivation for an integral, Riemann sum, this approach of choosing those individual points is one of three ways to find the area under the curve, Riemann sum. One is to use the left endpoint. The other is to use the right endpoint. What is the third case? Right in the middle. So those are the midpoints that I chose in my sequence. But did I find the area of a rectangle in that formula? No, I just kept adding those values together. Agreed? So to find the area of a rectangle, that is a midpoint, that is a midpoint, that is a midpoint. You simply multiply by the width that you have. Agreed? Now, what is that width? 1/7. Yes? So if you did 15 times 1/7, what do you get? 2.1 approximately. Does that number match with 2? Close? Yes? So, anytime you find an integral, or anytime you find a series, you are pretty much relating it to an integral. With me? So, right now, we are getting 15 because we did not look at the points that we sampled. Midpoint formula, you have that midpoint value, you multiply by the width. If you take that sum, multiplied by the width of 1/7, you would get 15/7, which is approximately 2.1. Good? Matches 2. Good? So integral with a continuous function is nothing but a series with a discrete sequence. Do we see the connection between the two? Of course, I have to scale this, but in other words, if you want to get to the exact answer, you've got to divide by that width, which is 7. But there is a connection between integral and series. Do we agree? Good? Okay. Are we clear? Before we move on, I'm going to write another property here. Or 2. Suppose if someone asks you, well, I start with 1 or go all the way up to 10, I would like to know 1 squared plus 2 squared plus 3 squared plus 4 squared all the way up to plus 10 squared. Can you give me the answer? Well, you can if you know this. 1 to n I squared n times n plus 1 times 2n plus 1 divided by 6. You just have to put 10 in there. So you would have 10 times 10 plus 1 times 2 times 10 plus 1. It's 10 times 11 times 21 over 6. That would be 35 multiplied by 11. The answer is 385. That would be the sum of squares if you sum from 1 to 10, so 1 squared plus 2 squared plus 3 squared, all the way up to 10 squared. Sum of cubes of n natural numbers. In other words, I would like to know 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed all the way up to some arbitrary n. So sum I equals 1 to n I cubed n times n plus 1 divided by 2 wide. Good. You can plug in and you will say, well, let's just do the past 2 times n equals 2. The n is 2, 1 cubed plus 2 cubed is 9. So you would have 2 times 2 plus 1, 3 divided by 2 squared. You got 9. Yes, sure, you can do up to 1,000, but you get the point. Agreed. That's the last important property. Going to sum from I equals 1 to n some constant k. What do you think the answer is? Earlier, I said if you have a constant, you can pull that constant out of the sum. Yes? So I could write it this way, k sum I equals 1 to n 1. What do you think that would be? Imagine you have a penny and you have a sequence of I equals 1 to 10, and you're adding the pennies. How many pennies do you have? The general term is a penny. I equals 1 to 10. How many pennies do you have? 10. I equals 1 to 100. How many pennies do you have? 100. I equals 1 to uppercase n. How many pennies do you have? Uppercase n. So this is simply uppercase n times n. Yes.
So what does that last one for? Because the other ones are like cube or square.
It's just sum of constants. The same constant. So the constant is k. I'm just adding that sum n times. Here is something. All of these series are finite series. Do we agree? Now, we don't look for convergence unless the series is an infinite series, because finite series will always converge. Do you agree? If you're adding only up to a finite number of terms, the answer is going to be finite. Yes or no? Yes. But if this is infinity, then it might blow up. Who knows? Well, if I change n here to infinity, will I get a finite series, a finite sum? No. I would like my bank account to be that way every night. Wouldn't it be great? Yes, but it's not going to happen. Tough. So that series is not going to converge. Well, If I change that to infinity, will that give me a finite sum? A convergent series, would it converge to a value? No, that's going to blow up because you're just adding numbers. Same there, and there. Agreed. Erase. So, will not converge, will not converge, will not converge, will not converge. None of these series are convergent series. Good. So when we talk about series, there are two types. One is convergent, the other is divergent. A series depends on the sequence, a sequence depends on its general term, so it is going to go back to the general term, which is why writing the general term is important, or writing it properly is important.